6.5, Properties of Logarithms. So we're going to work with properties. I'm going to tell you the ones that we'll work with majorly in this class. We're going to be working with 3. We're going to be working with 4, 5, 7 and 8 are the same exact things. They're just written backwards. So let's just say 7. And then these up here, they're useful. So those are the ones we're going to focus on today. So let's talk about 7, 3, 4, 5. So 7 is saying m equals n, then log a m equals log a n. Did you notice that they're just the same log with base? They cancel, and you're just left with the argument. 3 is called the log of product equals the sum of the logs. So when we're multiplying a logarithm, we can split up the argument using addition. The log of a quotient equals the difference of logs. So when we're dividing one logarithm, we can split it up with the arguments. We can split it up into 2 logarithms using minus. The log of a power equals the product of the power and the log. So the exponent can be moved to the front or it can go back. We're going to practice with these. So we're going to write each expression as a sum and or difference of logs, express powers as factors. I'll talk more about that after. So what we're going to do is just write each expression as a sum or difference. That's telling us to expand. So we want to make this multiple logarithms. So I know I'm going to have multiple logarithms, but I need to know what's happening inside the argument. So what is happening inside the argument? So inside the argument, we technically have 216 times x. So since we're multiplying, we're going to be using property 5. Since we're multiplying, we're going to be using property 3. So property 3 states that when we have one logarithm being multiplied, we can split it into 2 using an addition sign. So I'm going to write log twice because that's how many pieces I have in my argument. I have 2 pieces in my argument, 216 and x. Since I'm using property 3, I'm going to put them together with an addition symbol, and we put them in order. So 216 goes first, and then x goes second. So our answer is log 6 216 plus log 6x. And we did that using property 3. Alright, going to B, we have log base 5 z cubed. Now, they're not being multiplied, there's no division, none of that. So the only thing that we can do if we have log base 5 z cubed is we can move the exponent over using property 5. So using property 5, we're going to move over the exponent. So we'll have 3 log 5 z. Alright, moving on. So let's figure out what's happening in the argument. So in the argument, we have e times x plus 5. So since they're being multiplied, we're going to use property 3. So property 3 states that I get to split them up using an addition sign. So they're going to share ln, and the first one goes first, the second one goes second. And you would probably think we're done here, but we're not. I'll tell you why. ln and e are inverses of each other. So you know how like when we switch e, we switch it to ln, and when we have ln, we switch it to e? So these are already inverses of each other. Inverses cancel each other out, so we're actually left with 1. So we have 1 plus ln x plus 5. So that's just something that we need to pay attention to. Alright, next we have ln x cubed times the square root of 4 minus x, and this part right here, the 0 minus, or is less than x is less than 4, that's just the domain. Don't even worry about that. They have to give it to you unless you're solving. And we're not solving here, we're just expanding, so they have to give it to you. So just cross it out. Alright, so let's figure out what's happening inside the argument. So inside the argument, we're multiplying. So since we're multiplying, we're going to be using property 3. And property 3 states that we're going to separate them using an addition symbol. So we'll have ln x cubed and ln square root of 4 minus x. So now we can still simplify because we're not allowed to have that exponent here. We move it to the front. So using property 5, we're going to move it to the front. So we have 3 ln x. The part where it says express factors as powers, that's coming up right now. As a reminder, do you guys remember that the square root of x is technically x to the power of 1/2? Or let's say we have like the cube root of x squared, that's technically x to the power of 2/3. That's what we're talking about when we say express powers as factors. So we need to switch that square root of 4 minus x to have a fraction. So we'll have ln times of 4 minus x to the power of 1/2. It's 1/2 because there's a little 2 and always a 1 outside. Then again, we can move this over because we're not allowed to have it. So we can move it over using property 5. So we'll have 3 ln x plus 1/2 ln 4 minus x. Okay, part E. We have a bunch of stuff going on here. There's just a lot. So what we do is we're going to work from outside, then inside. So outside, we have this exponent on the outside. So that exponent is going to be moved to the front using property 5. So we'll have 1/4. And isn't that on the outside of the entire argument? So it needs to be on the outside of the entire logarithm, because it is. So we have ln x squared minus x minus 30 over x plus 7 cubed. Alright, now we start to focus inward. So big picture, what's happening inside the argument? So inside the argument is a division symbol. So we know, because it says division, using one of our properties, we're going to split this up. So using property 4, we can split this up with subtraction. So we still have 1/4 on the outside of everything. So we have ln, the top goes first, so x squared minus x minus 30, minus ln x plus 7 cubed. Now we see if there's anything more we can do. We can move over the exponent. We can move it over using property 5. So we'll have 1/4 ln x squared minus x minus 30 minus 3 ln x plus 7. Now we have to see if we are done. Can I move any exponents? Can I simplify anything? Can I do anything at all? We can. We can factor the trinomial. So let's factor. We have 1/4 around all the whole thing. So ln, we factor this. We can factor it down into x minus 6, x plus 5. And that's all minus 3 ln x plus 7. Can we do anything more? Guess what? We can. We have x minus 6 times x plus 5 in one of our arguments. So we need to use property 3 and split them up. So we have 1/4 ln x minus 6 plus ln x plus 5 minus 3 ln x plus 7. When all of your arguments are factored, separated, there's no exponents, the last thing you do is we're going to distribute the 1/4 to all of them. So we'll have 1/4 ln x minus 6 plus 1/4 ln x plus 5 minus, so 1/4 times 3, that's 3/4 ln x plus 7. Rewatch that one again. All right, now we're going to go the opposite way. Write each of the expression as a single logarithm. So single logarithm, that means one logarithm. So literally, we're going to work backwards. We're going to do everything backwards. So let's see. The first thing you want to do is, do we have any numbers in front? We do. Since we have numbers in front, we want to move them back. So we move them back using property 5. We'll have log 3 u to the 6th plus log 3 v to the 5th. So always move over your exponents, and then we figure out what's happening in between. So in between is a plus, so that's property 3. Property 3 states when you want one logarithm with the same base, you put them together with multiplication. So we have log 3 u to the 6th times v to the 5th. We can clean this up to be log 3 u to the 6th v to the 5th. You just get rid of the symbol. You don't need it there. All right. Let's go ahead and work this out. Let's see if there's any exponents from the front we can move. So there's no exponent here, but there is an exponent here. So we're going to move it using property 5. So we have log base 5 x squared minus 16 minus log base 5 x plus 4 to the 7th. Now we want to see what's happening in between. So in between is being a minus, so that's property 4. Property 4 states we divide with our logarithm, same base. So top goes first, bottom goes second, or sorry, right side goes second. Now how do I know if I'm done? I need to know, can I factor anything? Can I simplify anything? I can factor the top. So we can factor the top into x plus 4, x minus 4 over x plus 4 to the 7th. So what we have now is 1x plus 4, 1x minus 4, and on the bottom we have 7x plus 4s. So I can cancel out 1x plus 4, so 1 or 7 minus 1, we're left with 6. So our final answer is log 5 x minus 4 over x plus 4 to the 6th. Do you notice when we're working with them, we don't want any different symbols? If you're condensing, if you're doing to a single logarithm, do you notice how everything is minus or plus? Everything is minus or plus. Here, we have minus, we have plus, and we have division. We don't want that. We either want it to be all minus and plus, or all division and multiplication. So I need to fix this. I need to fix that. So while my bad. We need to fix this. So when we fix it, it's being divided. So we're going to use property 3. So we'll have log base 6, 5 minus log base 6x. And that's all plus log 6, 5. We can cancel out log 6, 5 because this is negative log 6, 5 and this is positive log 6, 5. So they cancel. The only thing we're left with is 14 log 6 square root of 3x minus 7 minus log 6x. Now we need to move over exponents, and also we're not allowed to work with radicals at all. We have to switch them always. So let's go ahead and switch this radical. We're going to switch it to 1/2. So we have 14 log base 6 3x minus 7 to the power of 1/2 minus log 6x. So now we're going to move over the exponent in the front. So using property 5, we're going to move it over. So we have log base 6, 3x minus 7. Half of 14 is 7 minus log base 6x. Now we figure out what they're doing with each other. So they're minusing. So using property 3, we're going to put it together with division. So we have log base 6 3x minus 7 to the 7th over x. And that's our final answer. When single logarithms should have exponents. Logarithms whose base is neither 10 nor e. So how can we solve logarithms? By plugging it into a calculator. So there's two things you can do. We can do log with base m over log with base a, or what we usually do is when they have the same log base, which they do here, you see how it's log base 3, log base 1/7. When they have the same log base, we can either use one of them. It doesn't matter, we can use both of them and you'll get the same exact answer. Because a natural logarithm is log base 10. So I'm going to show you both ways for both. So we're going to use change of base formula and a calculator to evaluate each of these. So first thing that we're going to do is, since I can't solve this, now why can't I solve this? Because it would be 3 to the power of y equals the square root of 5. I can't solve that. It's never going to be the same base. So since we can't solve it, we can do change of base. So what we'll do is we have fraction log. You see how this is the bottom number? It's on the bottom. It goes on the bottom. The one on top goes on top. Now we're not done yet because we're not allowed to have radicals. So we need to switch this to log 5 to the power of 1/2 over log 3. And I don't know about you, but we're not allowed to have those exponents there, so we need to move them. So we have 1/2 log 5 over log 3. That is the exact answer. For the approximate, we use our calculator. If you want the approximate, we're going to plug that in to the calculator. We're going to plug that in because your calculator knows square root of 5. We don't, but your calculator does. So for the approximate, we plug the first one in. So you can do it alpha y equals enter or piece by piece. I'm just going to do it piece by piece. So we have log square root of 5 enter divided by log 3. And we get our answer. So the approximate answer is 0.73. If we wanted to use ln, I'll do it in red. So I'll do this in red. We have ln over ln. The top goes on top and the little bottom number goes on the bottom. So we would switch it just like before, but I just want to show you with your calculator, you get the same thing. So we have log square root of 5, and then divided by log 3. See, we get the same answer. We would still need to switch this to 1/2 ln 5 and ln 3 to be the exact answer. Alright, now let's do our second one. So we're going to write log over log, and then the number on top is 6, and the number on the bottom position is 1/7. That is simplified. That's it. That's our answer. If we want to plug this into our calculator, so log 6, enter, divided by log 1/7, enter, and we get our answer of negative 0.921. So it's approximately negative 0.921. If you wanted to use ln, you can still use ln. So ln 6, enter, divided by ln 1 divided by 7, enter, and we get the same exact answer.